Hello and welcome to this year's Disruptive Innovation Festival. We're excited to be back here, and we're here in Amsterdam at the new headquarters for AMS Institute, and we're ready to kick off our talk today, which is entitled Cities of the Future, the link between smart and circular. So before we get into the details, let's start with a quick update on who we are and why we find this topic important. This year's talk is a collaboration between Metabolic and AMS Institute. We are both companies working within the city of Amsterdam on developing new approaches for urban development. And we both, as organizations, believe that cities as they are today need to rethink how they function in order to tackle some of the future challenges that they will face, things like climate change, population growth, and resource limits. So we've been working together on a joint program over the last year, and that program has been focused on finding solutions to some of these challenges that cities will face, and making our metropolitan regions more resilient. So yeah, to kick off, I'd like to introduce you to Professor Arjan van Timmeren. Arjan is the Scientific Director at AMS Institute, and to give you an idea of what AMS stands for, it's the Amsterdam Institute for Advanced Metropolitan Solutions. Did I get that right? Yes. And so Arjan and his team work within the city of Amsterdam, using it as what they call a living lab, where they develop and test urban innovative solutions to solve some of these challenges and to make our cities more resilient and sustainable. Arjan has a background in architecture, and in addition to his work at AMS, he's also a professor of environmental technology and design at the Delft University of Technology. Thanks for joining us, Arjan. And then over to Gerard Rumers. Gerard is our lead cities consultant at Metabolic. If you don't know, Metabolic is a consulting and venture building company, and we use primarily systems thinking as a framework, as well as a lot of data science and the development of new technologies to solve sustainability challenges. Gerard joined Metabolic in 2014. He's got a background in geography and spatial planning, as well as environmental science and sustainable development. And at Metabolic, we believe that cities are key in leading the transition to a circular economy. So Gerard and his team spend a lot of time crunching data, trying to figure out how city metabolisms function, and then where we can intervene in those systems to make our cities more resilient and sustainable. Welcome.
Thank you.
So without further ado, let's get to it. So we know that we need to rethink how cities function. We've got these two concepts that are spoken about a lot in the context of cities. We've got the smart city, which involves thinking about technology and connectedness, as it were. And then we've got the concept of the circular city, which talks a lot about closing of resource loops and regenerative design. These are all big concepts which we'll unpack later, hopefully. But let's start off with what we really want to get to the core of today is how these two topics intersect, where smart and circular, how they can work together, and what cities should be aiming for ultimately. So let's start off with you, Gerard. Could you give me an idea of what a circular city is? How would you describe the concept of a circular city?
Yeah. Well, I would say you've already mentioned urban metabolism as a term. So just as the human body, you can see that a city will also have a certain metabolism. It has a throughput of energy and resources that is driven by economic activities, production and consumption in the urban environment. And at the core of it, a circular city aims to be regenerative in that it recycles and reuses the energy and the resources that we see going through this urban metabolism. So it's about closing those material and energy cycles rather than taking a lot of resources from the hinterland and having them end up as either landfill or incinerated waste at the end of its life cycle.
So what kinds of flows would you be talking about when we talk about closing resource loops? What would a practical example of closing a resource loop in a city look like?
This could be, let's say, about the building materials that we use in the city. So you can think about buildings as material deposits, material banks, is what Thomas Rau coins them. And you can close those material cycles by ensuring that once a building is at the end of its life cycle, you can remove them in a good way. So rather than gluing them together or using them in a building in such a way that it becomes very difficult to demolish them and to tear them out, and you might have to break certain components or elements, you want to do this all with dry connections and with connections that are designed for disassembly. And in that way you can also regain both the economic value of those materials as well as the complexity of these elements and these products, and you can reuse them again rather than having to break them down or break them apart.
Great. Then Arjan, on the flip side, or perhaps the same side, how would you describe a smart city?
I think we will come later to the flip or same side because I think there's a lot of connection to be made.
Sure.
But smart cities are actually, they coined in 2007 by Sam Palmisano. He was the CEO of IBM. It says already something. So it was mostly about the integration of IT technology and all the opportunities which arise of this Internet of Everything in, let's say, sensing cities, behavior of citizens, but also the cities itself, their flows and the metabolism, as Gerard just was telling. In this, let's say, ocean of opportunities with technology, a lot of new real-time sensing opportunities arose, which makes it possible that behavior can be changed or can be informed, but at the same time that urban professionals can base decisions on that feedback from sensing. Smart cities, for us as an institute, actually, they are a bit more, they're more than just technology and the use of sensing technology in urban environments. For our institute, but I think in this we are together with Metabolic, citizens are more to the core of, let's say, solutions, and thus the feedback loops to the citizens and the way citizens are informed and are being, let's say, enabled to change their behavior in a continuous way. That's more important. So this is more, let's say, a human-oriented perspective of smart cities. So we actually prefer to speak of smart or intelligent citizens, which are much better than smart cities, because that suggests as if citizens are dumb or so, which is not the case, I think.
Great. And then, so just to dive a bit deeper into that, if I was a citizen in Amsterdam, what would a practical example of these kinds of feedback loops look like for me?
Well, there's many things to think of. For citizens, most common is that we have our iPhones, or our smartphones, I should say. These phones are based with all kinds of apps which tell you about the weather, about routes, but they also can tell, and these are apps we develop in our institute, about, let's say, air quality in different streets in the city. So you can not only base your different routes in the city on the shortest or the fastest connection, but also on the most healthy connection. And on the other side, this is the citizens' side, there's of course the urban professionals. Urban professionals would like to know if they demolish a building in one side of the city and some materials arise, which are opportunities for, let's say, circularity from another perspective of rebuilding it somewhere else. To match it with the building, say, of a new district or a new house or an apartment building in another area. And then also this information of what material is mined in a certain place and comes available at what quality of this material, how can it be reused. That's crucial as well, because in circularity, as you will know, every time you lift the material, it lowers the value. So the business case becomes more difficult. So you would really like to know at the moment when a material becomes available, be it a nutrient or, let's say, minerals from a building deconstruction site, that you don't want to lift it from one to another place or to store it. You would like to use it as soon as possible, because then the match is better and then the business case is brighter.
Great. So Gerard, what are some of the AMS and Metabolic obviously working on quite a few projects in this space? Can you give us examples of some of the projects that we're working on in regard to circular planning?
Yeah, well, I think one of the most prominent projects at the moment is the repair project, which is not a project that we are just working on together. It's a large European consortium that's working on this. The main topic for repair is to enable planners and urban professionals to start designing with flows, if I would put it in a nutshell. So with repair, we are trying to do what Arjan already mentioned. We're trying to map, for example, building materials in different building layers throughout the city, trying to create a geological map of the urban mine, if you will. But we're also doing this with, for example, food waste and organic waste streams and the nutrients that are encapsulated in that. So that's the information that you would need, but then we are also trying to create 3D models of those, and we are trying to create decision making support tools and software that then allow urban planners to start closing these material cycles optimally. So matching, for example, building and demolition waste with new developments, but also thinking about the best level at which to close the cycle on these organic waste flows, and thinking about the infrastructure that is related to that.
Arjan, could you give your opinion then on how smart and circular interact? I mean, can we have a city that is smart and not circular, and should we? Or should we have a city that is circular and not smart? How do these two concepts really interact, in your opinion?
Well, I think there's not, let's say, the one without the other. I think within this adapted context of smart, which I just explained, but I think so. There's a reciprocity between the both concepts, and the most important thing is that this reciprocity is between, let's say, user behavior and change and the dynamics, and let's say the opportunities of real-time feedback loops to, let's say, the user to really change the behavior at all times. And this is the matching. And then the complex side, why technology is of use here as a means, is that cities are so complex. If you look around you, we are living in our urban mine.
Yeah.
This is all around. But if you ask, let's say, any person in a building, he or she will not be aware what are the materials in this building. You can see a few, but you don't know what are the different materials which are actually the mine for a potential future new reuse. And I think making, let's say, making it possible at moments when these materials arise to be reused is quite important. And then in this double complex system as a city is, we need some intelligent system support of professionals and of citizens foremost.
And then I think a question that is on a lot of people's tongues when we talk about both smart and circular city development is, where do people come in? So how do we involve and empower citizens in shaping their neighborhoods and cities as we move through this transition?
Yeah.
Gerard, do you want to start us off?
Yeah, I'd love to. I think it's a very exciting topic. Let's go back to the example that Arjan just gave. We're living in an urban mine. We're quite literally sitting in one. I feel that one thing that combining the notions of smart and circular cities can do is to not only show where there is an economic and environmental potential for example, closing resource cycles, but also to give control over those resources back to a much broader group of stakeholders than is currently the case. So if I build my house, at this moment I have very little control over which materials go in there, how they're being used, and at the end of the life cycle of the building, nobody counts on me having an opinion about where they should go next. If you have a smart and circular city, those somewhat far-fetched notions suddenly become a reality, because I can start having a conversation with contractors and with developers about the way in which they design the buildings that I live in, that I work in. And if I actually own the buildings, I might also be able to benefit from the residual value that they have at the end of the life cycle. This goes for something like fixed assets like buildings, but it could even go for my organic wastes and the value that's within those. This could also be about the surplus of energy that I might produce if I have sufficient means to invest in those, and I might want to share that potential with the rest of the city. So I think in the broadest sense, a smart and circular city could really paint a picture in which citizens are much more actively governing their own resources at a lower geographical scale. So the topic of your PhD research was about which scales are optimal for closing resource cycles. I don't know the answer to that in the technical sense, but I do know that the more decentralized and self-governed some of these infrastructures are, and some of these resource systems are, the more adaptable they are. And I think in a future with many uncertainties around technological development, around the way that climate change might impact the way we live and the way we live in cities, having a more adaptive system and having more people on the table than is currently the case could be very beneficial and interesting.
Absolutely. Aaron, do you have anything to add to that?
Yes, I can confirm a lot. I think we are heading towards a society which is much more sustainable and much more, let's say, easy to govern and to run, based on distributed systems. So at lower scale levels, but altogether they form this complexity of a city. As an institute, AMS is a triple helix or even a quadruple helix. So where come the people in? Well, that's the quadruple. And so we are an institute which is based by three main universities, TU Delft, Wageningen University and MIT, together with private enterprises and with public, like the city of Amsterdam in this case, but also with people. And this quadruple helix is quite essential in our living lab concept. And this is also where Metabolic comes in. So you have applied, let's say, the testing of solutions and really joint initiatives in which we like to, let's say, on a small and controlled way with citizens, test all kinds of new innovations and find out if it works or not. And by doing so, making the, let's say, the scale up to society faster and sooner, I would say, that is really needed, and it's something which is lacking a lot in a lot of scientific approaches in the world. So here comes the good collaboration with Metabolic and AMS as well, as a good example of how you can really, let's say, practice scientific research, develop tools or develop solutions, but also implement them together, and by doing so include people and their feedback, because in the end they have to adopt a technology or a system or a solution, and only then their behavior might be like we suggested it should be changed. And this feedback by people is really something which is often overlooked and forgotten. Yeah.
Absolutely. Well, thank you both. I think it's been a really interesting discussion to see the sort of two sides from both of your varying backgrounds and to talk about how we are collaborating. I think there's a lot of exciting projects still to come, and if you'd like to keep in touch with what we're up to, you can visit either the Metabolic website or the AMS Institute website, and through that be able to get in touch with Kira or Ariane if you have further questions. But otherwise, thanks very much for joining us today.